Hello wonderful person, this is Anton, and today we're going to be discussing a new study based on a relatively recent discovery that, if confirmed, could fundamentally change some of our understanding on how the universe began and what it seems to be mostly made out of. And that's because not so long ago, actually just a few months ago from when I'm making this video, scientists discovered a somewhat unusual gravitational wave coming from a distant galaxy somewhere out there. But unlike previous detections that sometimes did actually have something mysterious, but were eventually explained one way or another, this particular gravitational wave was actually created by something extremely strange. And so in this video we're going to discuss exactly what happened here, the implications that this has on astrophysics, and why, if confirmed, this is a really exciting discovery. But here I guess let's start with a bit of a background, just in case you have no idea what we're discussing. And so first I guess let's briefly start with this. This is part of the LIGO-Virgo-Cagro collaboration, whose job for the past decade or so has essentially been pretty simple, trying to listen to the universe. Unlike other telescopes that usually focus on electromagnetic waves, here this collaboration focuses entirely on the waves of space-time itself, the idea that was proposed by Einstein, and the idea that we can now physically detect by watching these kilometer-long lasers oscillate once in a while. And so in the last decade, quite a few of these powerful gravitational waves have been discovered in a lot of locations, and so far the vast majority have essentially been created by colliding black holes. Two black holes orbiting one another that eventually started to approach each other closer and closer and eventually collided. But for many decades, scientists believed that these types of black holes can only form when massive stars undergo a supernova. They essentially collapse under their own gravity and form these massive objects. But in the last few years, some of the data coming from several observations additionally started to reveal certain black holes whose existence is just difficult to explain. And at first it was black holes with masses between 60 and 100 solar masses that scientists don't actually think should be produced by supernova. And in the last few years, at least two such collisions have been detected, with these mass gap or impossible mass black holes, whose origin is still very difficult to explain. Additionally, at least one of the detections was from an object that was an extremely low in mass neutron star that was also just a little bit strange. And so quite a few of these gravitational waves seem to have been formed by something that's, well, basically unknown. And so the standard way of black hole formation could not be applied to some of these objects. And that's because normally we expect the mass of these black holes to be at least 4 to 5 solar masses, but to potentially be less than 50. Although naturally quite a few objects of that mass have been discovered as well. But we do require a star with at least 8 solar masses to produce a black hole. Lighter stars cannot do this. So stars like our Sun, for example, are just going to become white dwarfs and release the rest of the mass as a kind of a beautiful nebula. And that's why we have these mass gaps when it comes to black holes and certain other objects. But importantly, according to modern science, there should not be any black hole less than 3 solar masses in mass. Mostly because no star explosion should produce anything less massive, unless this black hole was produced through some kind of a collision of two neutron stars that, instead of exploding, produced a tiny black hole. Now physically this should not happen, but I guess it might be possible. And that's where we have this new event that was only detected on November 12, 2025. So literally like 3 months ago from when I'm making this video. This is referred to as S25 1112 cm, a super unusual gravitational wave that was recently discussed in a study you can find in the description. And while compared to other detections, this one was actually pretty close. It involved the collision of two compact objects approximately 300 million light years away from us. So not the closest signal, but definitely not that far. And well, what makes this event so unusual is of course the mass. Based on the chirp, or the frequency produced by this gravitational wave, scientists determined that at least one of these objects was almost certainly less than 1 solar mass. In fact, the probability that this involved a subsolar mass object was at least 99%. Which already makes this detection extremely unusual. But obviously at first scientists assumed that, okay, maybe this was just some kind of a star, even a star similar to our Sun, just slamming into something more massive. Because in this case the mass is definitely less than a black hole and less than a typical neutron star. As a matter of fact, it's believed to be between 0.1 and 0.87 solar masses. But a collision with a star at this distance or even a collision with a neutron star, should also be producing some kind of a visual or electromagnetic source that should have been detected by other facilities. Yet in this case, right now, nothing has been seen yet. But as of today, there is no report of any flash or any massive explosion. And so quite a few researchers actually think that there's a slight chance we may be looking at the elusive primordial black holes that existed since the beginning of the universe. And so I guess let's briefly discuss the PBH or primordial black holes. These were actually proposed back in the 60s and the 70s by scientists like Yakov Zildovich, Igor Novikov, and Stephen Hawking. And Hawking actually believed that they can technically solve the dark matter mystery because, theoretically, if a lot of these exist all over the place, they can definitely explain all of the gravitational anomalies we seem to be observing. But the problem here was basically the fact that they actually would be pretty small in size and extremely challenging to detect. Even though they are black holes and even though technically they can consume a lot of mass, some of them, especially the ones with the mass of a typical planet, would be super small in size. As a matter of fact, some can even be smaller than a typical atom. But unlike regular black holes, these ones do not require a star to form. As a matter of fact, there are a lot of astrophysical explanations for how density perturbations themselves can physically form these right after the Big Bang. In fact, quite a few explanations involving early cosmology seem to result in these primordial black holes as a kind of a side effect. And so this would be something that formed in just a fraction of a second following the Big Bang, when the universe was extremely dense. And this would be just the result of direct collapse, not requiring any supernova. And because they formed before stars existed, they would not be limited by any mass rules. In other words, they can exist in a variety of different masses. They could be as light as an asteroid, or as massive as a whole galaxy. And once again, they would also be able to explain pretty much all of the dark matter observations. Since we know that approximately 85% of matter seems to be invisible to us, just as Hawking predicted, it could be black holes. And that's of course why this detection is so super exciting. If there's a way to prove that this detection or this collision involved a primordial black hole, it could definitively confirm the existence of black holes as dark matter, and of course confirm the existence of these primordial black holes that seem to be just very hidden and are just super difficult to see. And because this would imply a vast population of these ancient black holes, naturally some of them could be even relatively close to us, possibly even right here in the outer solar system. As a matter of fact, as we've discussed several years ago, at least one explanation for the mysterious Planet 9 effects was basically a primordial black hole. Now, that's obviously not something we can prove anytime soon, but basically this is not science fiction and is something scientists are actively exploring. And if S251112cm is confirmed to be a primordial black hole, it would prove that these objects are real and make up a significant portion, if not all of the dark matter particles. Well, the recent studies suggest that if this one detection is real, it means that at least 4% of all dark matter must be made out of ancient black holes. So maybe not all of it is black holes, but at least some of it is. And the thing is, this is not the only study with some evidence for their existence. As a matter of fact, some of the recent observations from the James Webb Space Telescope have also found certain strange objects, such as the mysterious little red dots, and especially the object referred to as QSO-1. This contains a supermassive black hole that's just way too big for its own galaxy. It's about 50 million solar masses in mass, but existed just a few 100 million years following the Big Bang, so it's super difficult to explain how it managed to form so quickly. Traditional models suggest this should have taken billions of years. But recent simulations on primordial black holes suggest that it's definitely possible if this just collapsed directly from a primordial overdensity following the Big Bang. And so here, by sitting in the center of a young galaxy and rapidly collecting gas, it basically allowed this galaxy and this object to grow much bigger and to glow much brighter, which would explain exactly what we're seeing. And additionally, the existence of these primordial black holes can solve a lot of other mysteries in astronomy that still do not have explanations. For example, certain explosions of white dwarf or type 1a supernova seem to follow different patterns from what's predicted. And so here, if a tiny asteroid mass primordial black hole passes through a white dwarf, the intense gravity could actually ignite the star from within and explode it on its own, creating a supernova that doesn't look like the rest. And since some of these have been discovered and could not be explained yet, here primordial black holes could maybe explain this as well. And at the same time, assuming the study is correct, it also highlights the need for a different type of a search in the data from gravitational wave detectors. And that's because right now most researchers focus on star-like objects with at least several solar masses in mass. But this paper argues that even small signals can be extremely important because that's where the most fundamental physics, like the nature of dark matter, might actually be hidden. But at the same time, we also have to mention the fact that it may still be a kind of a false positive. And that's because similar objects have an alarm rate of 1 per 4 years. In other words, statistically, there's still a chance that this is actually a nothing burger. And so only a final analysis involving additional data is going to confirm its origin. But if confirmed, it would be one of the most significant discoveries in recent cosmological history. It essentially would confirm the existence of tiny black holes and of course suggest that they can explain dark matter. Although chances are we're not going to know much more for at least a few months because this is definitely a groundbreaking discovery and will require a lot of examination. But until then, or until we hear something else, check out some of the previous videos on a very similar topic in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else. Support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.